Hello, good evening, everyone. Welcome to all on this channel. So, those who are live on the session, give a response on the chat. I'm waiting for that. Good evening, everyone. Good evening. Am I audible clearly? Am I visible clearly? Tell me fast so that we can start our session as soon as possible. So, we won't be wasting our time. Very quickly, we are going to start the session. Just let me know. Everything is perfect to start our session. Just let me know. Perfect. Someone has joined the session. Yes, good evening. Okay. So I'm just starting now. I'm starting the session now. And let other people join. So as you can see on the slide, the topic for today's session is motion in straight line and motion in plane. So I'm going to give you a brief idea about these topics, and then again we'll be practicing few questions. So I've taken few questions from PYQs and some other questions are also there as I normally do, and then a brief idea, a brief theory, and a quick formula, and then straight away we are going to solve few problems so that you get an entire idea about the this chapter, right? Okay, what are those concepts that we need to study here, and what are the type of question that we have to practice. So just we should start as soon as start fast. So as in, like, when I say about the kinematics, so this is the first chapter of class 11 that you study, or in kinematics we study about the motion of the particle, right? So we have to study kinematics, like motion in one dimension, motion of the particle in one dimension, and then motion in 2D, right? Motion in 2D, motion in two dimension. So motion in 2D, or we can also call as motion in plane, motion in plane. And one of the example is projectile motion. In projectile motion, what will happen? So a particle will be projected suppose somewhere here with some speed u at an angle theta. So this is going to follow this kind of trajectory, and you can see that at any instant we can write the position of the particle by two coordinate x and y. So x and y are the two coordinate by which we can write down the position of the particle at any instant of time. Here, let's say this is the point x equals to 0, and a particle starts moving along this straight line. So at any instant of time, the position of the particle can be given as some x equals to x naught, right? So here the particle is moving in a straight line, so its position can be represented by a single coordinate, right? X or y, or it can be z also. So this is motion in 1D, this is motion in 2D. So what I'm going to do here is, the basic fundamental is, you have to first learn how do we analyze the motion of a particle in one dimension, and the same concept will be applied when I'm dealing with motion in plane or motion in two dimension. So whenever I'm talking about motion in two dimensions, so this is one axis, let's say this is x axis and this is y axis. So I can analyze the motion of the particle along the x direction, and separately I can analyze the motion of the particle along the y axis. So analyzing the motion of the particle along these two perpendicular direction, that is x and y, we are going to use the concept of motion in 1D only, right? So same concept what we are studying here will be applicable here as well, but the only difference is that here the motion of the particle was along only one axis, here the particle will be moving along x and y direction. So we have to separately analyze motion along x and motion along y. So to start with, whenever the particle starts moving, so definitely it will be having some physical quantities defined for it, distance displacement, velocity, acceleration. These are different quantities that are defined for a particle. So when the particle is not moving, when the particle is in the state of rest, it is not going to cover any path length. So the distance will become 0. Displacement will be 0. Since it is not moving, velocity 0. Since it is not moving, no force is acting on it. Nothing is happening. So its acceleration is also 0. But when a particle starts moving, then there will be some specific values for these physical quantities. It is going to have some value for distance, displacement, velocity and acceleration. So first of all, how do we define that the given particle is moving or not moving, right? So like the fundamental thing is what? Whenever we have to define whether the particle is moving or not, so we have to, like, this is the particle located over here. So I'm going to take a reference point, that this is a reference point, like O is my reference point, and I'm having an observer here. So particle is moving or not moving, for that we need to have a reference point and we need to have an observer to write the observations, right? So whenever a particle is located here and this is my reference point and here is my observer, so if you'll see that the position vector of this particle, let's say this particle is P and this point is O, so the position vector of this particle is what? OP vector. OP vector is what? Position vector. This is the position vector of particle P with respect to the reference point. So whatever reference point you have taken, with respect to that reference point, the position vector of the particle is defined like this, and I'm calling this vector as R vector. So now this observer will see that this R vector is changing or not changing, right? He started looking at this point object at, let's say, t equals to 0 time, and is continuously looking or observing that particle. And if he figures out that as the time passes, but this vector is not changing, this R vector is not changing in terms of magnitude, not changing in terms of direction, so it means this R vector is constant. And when this R vector is constant, it means the particle is not moving. So this is a very fundamental definition of how we define the condition of rest and motion. If dr by dt is equals to 0, it means what? R vector equals to constant, and it means it is not changing. If it is not changing, particle is said to be in the condition of particle is in rest. Particle is in the condition of rest. And if R vector is changing, so we'll be having dr by dt, some value will be there. It is not going to be 0. This dr by dt will be 0 only when this R vector is constant or R vector is not defined, in case like it is a null vector. So in that case, dr by dt will be 0. Otherwise, dr by dt is not going to be 0. And if dr by dt is not 0, it means this R vector is changing with time. Are you getting that? R vector is changing with time. So when you have this R vector which is changing with time, then you will call that the given particle is in motion. So particle P will be in motion. And it really makes sense, because whether a particle is moving or not moving, that entirely depends on what is my reference point and who is the observer, means by what frame I am looking at the object. So in different chapters you might have studied, sometimes the motion of the particle is analyzed from center of mass frame. Sometimes it is written that what will be the velocity of the object as seen from the block or seen from the car. So if you look at the motion of the particle from different locations, different places, or from like different places, different objects, then the motion of the same object will be different for all the different observers. So motion is defined relatively and absolutely it cannot be defined. So this is very, very important point. So if you have to define whether the particle is moving or not moving, first you have to check, first you have to select a reference point, an observer, then you have to see the position vector, and then you have to see whether that position vector is changing or not changing. So like this we can define whether the particle is moving or not moving. Once we find out that the particle is moving, so these are some basic terminology: distance, total path length covered, right? This is total path length covered. This is the total path length covered. Then comes the displacement. Then comes the displacement. This is what? This is the shortest distance between any 2 points. So let's say, we'll understand it very quickly, that let's say when that the particle starts from point A and it goes to point B like this. So this particle is following this kind of some random path to go from A to B, and in this case if I have to write down the displacement of the particle, then straight away I'm going to join A and B. So this green line between A and B represent the displacement, and the length of this yellow path represents length. Yeah, I'm talking about the length. Total length is distance, right? So you can understand that when particle travels in a straight line path, then distance and displacement both are equal. But if the particle changes its direction, or it returns back, or it is changing direction, then distance and displacement will be different in magnitude. And then we have one more quantity, that is speed, and that is defined as the rate of change of distance, or the distance traveled by the body divided by time. SI unit will be meter per second, okay? Meter per second. Then velocity we have. Velocity is what? Displacement over time. So this is the small difference we have. Displacement over time, and the unit will be again meter per second. So these are quantities we have: speed, velocity, distance, displacement. Again, as I told you, when the particle is traveling in a straight line path without changing its direction, without returning back, then in such case distance and displacement will be equal. And otherwise, if the particle is changing its direction of motion, then distance and displacement will be different in magnitude. Similarly, we have defined speed and velocity. Then we have one more term, that is acceleration. So how do we define acceleration? Acceleration is defined when we said that there is a change in the velocity of the particle. So if, let's say, the change in velocity of the particle is dv in time dt, then acceleration of the particle is written as dv by dt. So you all understand this thing, what is dv, what is dt and all. So if the velocity of the particle is changing by an amount dv and the time taken is dt for that, so acceleration will be defined as dv by dt at that point. And this is known as instantaneous acceleration. Instantaneous acceleration. And let's say if the time duration is comparatively larger, then we'll say that like between two different points, or between two time t1 and t2, where the difference is comparatively larger, the change in velocity is delta v, and that time difference is delta t I'm writing. So acceleration is delta v by delta t. So in this duration of delta t, this is what? Average acceleration. This is average acceleration. I hope you people are following this. So this is how we define the average acceleration and instantaneous acceleration. The only difference is that when I'm writing average acceleration, this change in time is comparatively larger, and when I'm writing instantaneous acceleration, then this have to be an instantaneous time. It have to be an instant of time. So this dt have to be very, very small. So this dt is very, very small. It means delta t value is approximately tending to 0. So when this will be very small, then it will be representing the instantaneous acceleration. So we have discussed like distance, displacement, speed, velocity and acceleration. Then I am coming to the next part where few students gets confused that when I am talking about acceleration, so acceleration will come into the picture only when velocity vector will be changing. Only when the velocity vector will be changing. So velocity can change in magnitude or direction or in both, right? Suppose the magnitude of velocity changing, still there will be some acceleration. If the direction of velocity changing, still there will be an acceleration. If both magnitude and direction are changing, then also there will be some acceleration. So acceleration simply means that the velocity of the particle will be changing. So let's say in this case, the particle is moving with constant speed on this circular path. So here, if we'll see the direction of velocity, it will be upward. At this point, the velocity will be like this. Here, the velocity will be in the downward direction. Here, the direction of velocity is this one, right? So as you can see, this particle is moving here in anti-clockwise direction. So continuously, the direction of the velocity vector is changing. So continuously, velocity vector is changing the direction. And since this velocity vector is continuously changing the direction, there will be acceleration on this particle. And the particle is going to experience an acceleration. Without acceleration, this velocity vector cannot change. Here, since the velocity is constant, the velocity vector or the velocity vector is v vector is changing in direction, right? It's changing in direction. But you know, there are certain cases when a particle starts moving on this circular path and this v is increasing with time, right? V is increasing with time. So as it moves on, it will move fast, it will move fast, it will move fast, right? Continuously the speed of the particle is increasing. So in this case, direction is already, I can see that direction of the velocity vector is already changing. It's not constant. And the magnitude is also changing, right? So I can see here that velocity vector changes in both magnitude and direction. Both magnitude and direction. So different type of possibilities are there where only magnitude can change, only direction can change, both magnitude and direction can change. So depending on different type of situations, we can have different trajectory of the particle of the body where the particle can travel in different path. What is the angle between velocity and acceleration and all these things. So different possibilities can arise. So I'll be just starting with the first case where the particle is moving along the straight line, only moving along the straight line. So if I'm saying the particle is moving with constant velocity on a straight line path, it is moving along a straight line path and it's not changing direction. And since this v is constant, this will be known as uniform motion. This will be known as uniform motion. And for such kind of motion, only equation I can write down is distance equals to speed into time. The only equation I can write down is distance equals to speed into time. Some students are telling me that handwriting is too small. Okay, I'll take big fonts, don't worry. And anything else, I'll see that, okay? And thank you, Mamta. And the duration of the class will be 1 hour. And good evening, everyone. So I'll write in big fonts, okay? No worries. I'll write that. So distance equals to what? Speed into time. So this is the condition of uniform motion, that velocity should be constant, no change in direction should be there, no change in magnitude should be there, okay? Both magnitude and direction should be fixed. Then we'll call it as uniform motion. So this is the only equation we are going to use in such scenario, right? And when I'm talking about when there is acceleration. This was the case when the acceleration was 0, when there was no acceleration. So when there is no acceleration, it is known as uniform motion. I am talking about the next case when acceleration is acting on the body, but it is constant. It is a constant acceleration. So one thing where some student gets confused is that when I'm asking, let's say a body is accelerating. So what do you mean by that? What do you mean by that when a body is accelerating? Does it mean that the particle is speeding up, or it means it is slowing down? What is the correct statement? Can you tell me that? When I am saying that a particle is accelerating, does it mean speeding up or slowing down? Any answer for this one? Any answer for this one? Yeah. So when I'm saying that a particle is accelerating, it means both possibilities are there. The particle can also speed up, or it can also slow down. The particle can also speed up, or it can also slow down. Both are possible, right? Acceleration does not mean speed up. Acceleration does not mean speed up. Mind it, you can make a note of it. When I'm saying that the particle is accelerating, it only means that there is a change in velocity. It does not mean the particle's speed is increasing or decreasing, right? So when I'm saying acceleration is there, it means speed up is also possibility and slow down is also possibility. But when I'm saying retardation, a specific word is there, retardation. So retardation means what? Slowing down. Means the particle will be slowing down. So when this kind of situations will arise, when the particle is slowing down or when the particle will be speeding up. So simply you have to understand that, let's say we are having some particle here and I'm giving a velocity in this direction, and the acceleration is also acting in the same direction. So whenever acceleration and velocity both are in same direction, when A and V are in same direction. Now I am using bigger fonts. Can you see this? Is it fine now? I am using bigger fonts. So when acceleration velocity are in same direction, particle will speed up. Particle will speed up. So sometimes student gets confused. They think that acceleration means speeding up, but that's not the correct thing. Now the other way can be what? When this block is there, this is moving in this direction and the acceleration is acting in the opposite direction. When velocity vector and acceleration vector are in opposite direction, they are acting 180 degree to each other. In such scenario, A and V are in opposite direction. A and V are in opposite direction. So particle will slow down. Particle will slow down. Okay. So whenever acceleration and velocity are in same direction, the particle will speed up. Otherwise, it is going to slow down. Now coming to the next part. So I have told you about the two different aspects of acceleration. Now coming to the third part, let's say there is some situation when the particle's velocity is here in this direction and the acceleration is acting perpendicular to the velocity, right? When velocity and acceleration are perpendicular to each other, then what will happen? This acceleration is, since perpendicular to the direction of velocity, it cannot change the magnitude, right? Here in this case, acceleration cannot change the magnitude of velocity, cannot change the magnitude of the velocity. It can only change the direction, right? It can only change the direction. So I'm just giving you all the important concepts of this chapter where most people get stuck. So when velocity and acceleration are perpendicular, then magnitude will not be changed, only the direction can be changed. Now you will definitely have a question in your mind. Okay sir, one possibility is that when velocity acceleration are in same direction, the other case is velocity acceleration are in opposite direction, the third case is velocity acceleration are perpendicular to each other, then fourth case is what? Let's say ki this is velocity and this is acceleration, okay? So they are making some acute angle theta between the velocity and acceleration, okay? So when velocity and acceleration are acting at an angle of theta, so I can do what? I can take component of acceleration, one component here and one component perpendicular to the velocity. So the component in the direction of velocity will be a cos theta and this component will be a sin theta. Now you can see that this component a cos theta is acting in the direction of velocity, so it is going to change the velocity. Because of this a cos theta component, the velocity of the particle will increase. Why? Because acceleration and velocity are in same direction, and when they are in same direction, the velocity should increase, right? And due to this component a sin theta, which is perpendicular to velocity, so it is not going to change the magnitude of this velocity. It is only going to change the direction of this velocity. So I hope this is clear. Thank you guys for some appreciation. I am trying my level best to make you understand these simple concepts, some tricky concepts of kinematics. So whenever you have this a sin theta perpendicular to velocity, so because of this component, direction will be changed. Direction will be changed. And because of this component, this velocity will increase. Velocity will increase. So we can think of one more situation when the velocity and acceleration are making an angle greater than 90 degree. So I am coming, just a minute. So let's say one more situation. This is velocity vector and this is acceleration, right? So velocity and acceleration are make an angle of greater than 90 degree. So it is an obtuse angle, right? So again I'll do the same thing, right? I'll take up a component which is perpendicular to velocity, this component. So let's say this angle is theta. No, let's say this angle is theta, right? This angle is theta. So one component of A is here, A cos theta. And one component is here. So let's say this is A sin theta. Now can you tell me which component is responsible for the change in direction? The component which is perpendicular to velocity. Velocity, and this is A sin theta, 90 degree. So because of this component, direction will be changed. Direction will be changed. Direction will be changed, okay? And because of this component A cos theta, and it is acting in the opposite direction of the velocity. This is acting in the opposite direction of the velocity. So it will try to slow down. So due to this component, velocity will be decreased. Velocity will be decreased. So it will slow down. Okay, it will slow down the particle. So now we have understood all these scenarios, that whenever you have the velocity and acceleration at some angle theta, so what is going to happen? So after understanding all these concepts, and we have taken the first case to be acceleration to be constant, right? So when the acceleration is constant, and otherwise we generally have the result as velocity. If x represent the displacement of the particle, X represents displacement of the particle and V represent the velocity, and velocity is defined as dx by dt. So when you differentiate the displacement with respect to time, then you are going to get velocity, and since acceleration is written as rate of change of velocity, this is dv by dt, or it can be written as the second derivative of the displacement d2x upon dt square. So this is how we can write down displacement, velocity and acceleration. So you can see one thing here, if we have displacement function, so if I differentiate this function with respect to time, I am going to get the velocity, and this is again differentiated with respect to time, I will be getting acceleration. So acceleration is what? It is the second derivative of displacement with respect to time, or it is the differentiation of velocity with respect to time. So both are same thing, right? So this is how we can write down the displacement, velocity and acceleration. So if we have displacement, velocity and acceleration, you can understand one thing. So by differentiating displacement with respect to time, I am getting velocity. Differentiating velocity with respect to time, I am getting acceleration. And if I have to get velocity from acceleration, I have to perform the reverse process, and the reverse process of differentiation is integration. So if I have to get velocity from acceleration, I have to integrate from velocity to displacement. Again we have to integrate, and we'll integrate with respect to the same variable. So let's say x is a function of time, let's say this is a function of time. So if I'll differentiate it with respect to time, then I'll be getting velocity, and if I'll be differentiating velocity as a with respect to time, differentiation with respect to time, I'll be getting acceleration, and from acceleration to velocity again integrate with respect to t. So you have to integrate and differentiate with respect to the same variable. So if you are differentiating with respect to time, again you are differentiating with respect to time. So from a to v, you want the function of velocity from acceleration, you have to integrate with respect to time, again you have to integrate with respect to time. And you know that whenever we differentiate an algebraic function, its degree is reduced by 1. Suppose I am having a function of the power 3, so this is a cubic function. So after one differentiation, it becomes x square type of function, right? It becomes a function of x to the power 2, x raised to the power of 2. So the degree has reduced by 1, because if you know the formula, differentiation of x power n is what? N into x raised to n minus 1. So you can see here the given function was having the degree as n, and the differentiated function is having the degree n minus 1. So whenever we differentiate an algebraic function, its degree is going to reduce by 1. So let's say this was a function x equals to some t square kind of function. So this is having the degree as 2, and after one differentiation the degree will become 1, and the degree is 1, it means what? It is a linear function, and after one more differentiation it will become a function of degree 0. And what do you mean by a function of degree 0? It is nothing but a constant function. So whenever you have the displacement which is a function of t raised to the power of 2, velocity should be a function of t raised to power 1, and acceleration will be a function of t raised to the power of 0, and t raised to 0 means it is a constant function. So if you will see here x equals to some t square, it means it is a parabolic function. It is a parabolic function, and if you will differentiate it, then you will be getting velocity, and velocity is the function of t raised to the power of 1, means it is a linear function. So if your displacement versus time graph is parabola, then velocity versus time graph will be a linear function. It will be a straight line function, and acceleration will be a constant. Similarly, if you are coming from a to v, you are integrating it, and whenever we integrate a function, its degree will be increased by 1, and again coming from v to x, again the degree will be increased by 1. So whenever we differentiate an algebraic function, its degree is reduced by 1. Whenever we integrate a function, its degree is increased by 1. So like this we can understand this basic fundamental, And now I'm going to give you a few examples. Uh, so let's say we have, I'm saying that, let's say I'm having displacement as the function of 2t square plus 6t plus 9. Okay. So you can see here the given displacement of the particle is given as 2t square plus 6t plus 9, and here the maximum power of t is 2. So its degree is 2. So it is going to be a parabolic function. So if I'll draw a graph between x and t, it will be a parabolic function, and since the coefficient of t square is positive, it will be an upward parabola. It is going to be an upward parabola. Okay. So from here I want to find out the velocity of the body. So velocity is defined as rate of change of displacement. So velocity will be written as dx by dt, and if I'll do the dx by dt here, so what I am going to get here is 4t plus 6, and the differentiation of constant is 0. So 9 is a constant here, and its differentiation will become 0. So velocity is what? 40 plus 6. Okay. So from the given displacement function, I have calculated the velocity function. Okay. And if I have to find out acceleration, so I know that acceleration is dv by dt. So you have to differentiate this velocity function one more time with respect to time, and then you will be getting the acceleration. So acceleration is what? Differentiation of 40 will be 4, and then differentiation of 6 will be 0. So I am getting acceleration equals to 4. Okay. So now you can see that when we have got the acceleration to be 4, which is nothing but it's a constant function. It's a constant function. So here the degree is what? T power 0. This acceleration is not depending on t. It means t is having the power of 0. Here the t is having power of 1, and here t is having power of 2. So this was the only concept I was telling in my previous slide, that whenever you differentiate this function, algebraic function, your degree is going to reduce by 1. So it was having degree 2, this is having degree 1, and this is having degree 0, because it was having 1. So it will be again reduced by 1, it will become 0. So this is a parabolic function. So this concept will help you to solve the questions based on graph. Okay. While solving the question based on graph, you will be requiring this much of information. Okay. So velocity is linear function, and this is constant. So generally in NEET exam, they will give you functions either parabolic or linear or constant. Okay. Generally 99.99% of the time they will never give you a function, mathematical function, which is of degree higher than 2, because a degree higher than 2 will be 3, 4, 5 like this, and if the degree is 3, then it will be cubic function, and it will be having maximum 3 roots, right? So then it will be difficult to plot. So it's not required for NEET exam. So 99.99% of the time it is expected that whatever the graph or the function that you have to plot will be of the degree 0, 1 and 2. So degree 0 means constant function, degree 1 means it's a straight line function. Okay. And degree 2 means it is going to be a parabolic function. So I guess this is quite clear to you. I'm taking another example. Let's say acceleration is what? Acceleration is what? T. Okay. Or let's say 4t. Acceleration of a particle is given as 4t. From here I have to find out the velocity and displacement of the particle. So what I'm going to do here is, acceleration can be written as dv by dt. Okay. And this is 4t. From here I can write down dv as what? 4t dt. I'll integrate both sides. So integrating dv means what? I'll be getting v here. 4 is constant outside the integration. And then inside the integration I'm getting t dt. And the integration of t dt is what? T square by 2. And then some integration constant will be there. So this is 2t square plus constant. Okay. So velocity of the particle is what? 2t square plus c. So like such questions are asked in exam. Multiple times these questions have been asked. Kashika is there. Hi Kashika. Correct. Someone has given the answer. Very good. So uh, very good. Uh, you all are doing a fantastic job. So just connected, stay connected, take the classes properly, write down it, है ना? And that will help you a lot. So from acceleration we have calculated velocity, and from this velocity I can also calculate the displacement of the body. Velocity can be written as dx by dt, and this is 2t square plus c. Okay, from here dx can be written as 2t square plus c dt. Okay, then I'll integrate it and I'll find the displacement function. So by differentiation and integration we can find out displacement, velocity and acceleration if any one of them is given to us. So let's say they have given acceleration, so remaining two can be obtained. If they have given velocity, still again the remaining two can be obtained. So like this we have few questions to practice. So let's come in here, see this question. Now you will be able to understand and you can apply the concept here to get the answer. So it's given that the position of the particle is given by RT equals to 4t I cap plus 2t square j cap minus 5 k cap, where the t is in seconds, r is in meter, and find the magnitude and direction of the velocity at t equals to 1 seconds with respect to x-axis. So as I told you, velocity is defined as rate of change of position. So position function is already given, right? This is the position of the particle. R is the position of the particle. So velocity is what? Rate of change of position. So it is going to be dr by dt. So just differentiate this function. So I'll be getting 4 constant and the differentiation of t is 1. And this is I cap, okay? Then plus 2 is constant outside. Differentiation of t square is what? 2t. And it is j cap. And see, 5 is constant, right? And the differentiation of constant is what? Differentiation of constant is 0. So I am not going to write it. So let's see what I've got. Velocity vector is 4 I cap plus 4t j cap. This is the expression for the velocity I have obtained. But again, you can see one condition is given. They are saying that find the magnitude and direction of velocity at t equals to 1 second. You have to find out the velocity at t equals to 1 second. So in this function put t equals to 1. So v vector I am getting as 4 I cap plus 4 j cap. Okay. So this is my velocity vector at t equals to 1 second. So you can see 4 I cap plus 4 j cap means the coefficient of I is 4, the coefficient of j is also 4. Means the x component of the velocity is 4 meter per second and the y component of the velocity is also 4 meter per second. So both the component are same. So if I want to plot here in vector form, so it's like that, the velocity is like this, okay? So it is having two components, so I'll be using a different pen color to show that. So this is velocity vector, okay? And this velocity vector is having two components, this is vx and vy. This is also 4 and this is also 4. This is the meaning of this statement. It is 4 I cap plus 4 j cap, right? When the magnitude along the x direction is also 4, magnitude along the j direction is also 4. So this is 4, this is 4 meter per second, okay? Now they are asking the direction of velocity, okay, with respect to x-axis. So this is your x-axis, this is your y-axis. You need to find out this angle. So this is 4 and this is 4. So tan theta is what? Perpendicular upon base. This is 4, this is 4. So theta is 45 degree. So this velocity is acting angle of 45 degree from the positive x-axis in the anti-clockwise direction. So the magnitude of v vector is what? The magnitude of this is under root of 4 square plus 4 square. So this is 4 root 2. This is 4 root 2. Okay. So the correct answer is A. 4 root 2 meter per second and 45 degree. So have you understood this? Easy to understand, right? Yeah. Coming to the next question. Coming to the next questions. two cars P and Q start from a point at the same time in a straight line, and their positions are represented by this. So this is the position of the car P and this is the position of car Q. Okay. At what time do the cars have the same velocity? It's asking that what is the time when the velocity of the two cars is same. So they have given us xp equals to at plus bt square. So from the displacement or the position function, can we calculate the velocity? Yes, definitely. So velocity of p is d by dt of xp. So I have to differentiate this function. So it is a plus 2bt. Similarly, the displacement of q is given as ft minus t square. So velocity of q is what? Differentiation of this function. So this is f minus 2t. Okay. So we have got the velocity of the car P and the velocity of car Q, and it is asked that at what time they will have the same velocity. So we are having Vp and Vq. So let's equate them. Vp equals to Vq. This is what we are required to do. So velocity of P is what? A plus 2bt, and this should be equals to what? F 2bt plus 2t equals to f minus a. Taking t 2t common here, I am getting b plus 1, and that is equals to f minus a. Solving this for t, this is f minus a divided by 2 times b plus 1. So we have got the time when the velocity of the two cars will be equal, and that is f minus a upon 2 times of b plus 1. So this is the B option. B is the correct answer. Okay. How's the session going on? Can you comment here and tell me? Can you comment here and tell me? Have you understood some concepts? Can you apply these concepts here? So with the help of questions, you can learn how to apply these concepts. Okay. Now coming to the next question. It's been given that again a particle is moving along a straight line OX, and at time t the distance of the particle from O is given by, so the distance of the particle from origin means the position of the particle is given 40 plus 12t minus t cube. Okay, this is the function. How long would the particle travel before coming to rest? So it's given that the particle has started from here point 0, okay, and it is traveling along x direction. This is x direction. Okay, this particle is traveling here. So they are saying that this particle will be coming to rest, means ultimately this particle will come to rest. Rest means v equals to 0, means after some time the velocity of the particle will become 0. So before coming to 0, how much distance the particle will travel? This has been asked. So first we'll check that when time was 0, so the x value was 40. This was x equals to 40. This point from where the particle started, this was 40. Okay, this started traveling in x direction, and here the time was 0. Okay, this is the information we have. At t equals to 0, particle was located at 40. So particle is located at 40. Now it started traveling in this direction, and after some time it will stop. So before stopping, how much distance it is going to travel? This has been asked. So first we'll find out the time when the velocity will become 0. So this is pretty simple. I'll differentiate this function and I'll find out the velocity. Okay, velocity is defined as the rate of change of displacement. So velocity is dx by dt. So differentiation of 40 will be 0. Yes, then it will be 12 minus 3t square. This is the differentiation of this function, and this is velocity. And for velocity to be 0, I have to write down this as 12 equals to 3t square, and solving this I am getting t equals to plus minus 2. Okay, and time In physics, we don't consider negative time. So I am only considering t equals to 2 seconds. So at t equals to 2, the velocity of the particle becomes 0. So 2 seconds, at t equals to 2 seconds, the velocity of the particle becomes 0. So now I'll see that at t equals to 2, what is the position of the particle? Okay. So this is x equals to 40 plus 12 into 2 minus 2 cube, right? This is 40 plus 24 minus 8. So 24 minus 8 is 16. 16 plus 40 is 56. So at x equals to 2, at t equals to 2 second, the particle is located at 56. And at t equals to 0, it was located at 40. So how much distance the particle has traveled? Let's say this is equals to t equals to 2 and this is x equals to 56. And this was x equals to 40. So how much this distance? This is 16 meter. Yes or no? 16 meter. So sometimes what will happen? The students will make a mistake here. They will put t, they will find out this thing. They will find out velocity, they will make it 0, they will calculate t equals to 2, and then they will put t equals to 2 here, and they will get 56. And since 56 is in option C for Chennai, they will mark it and they will get it wrong. Because you don't have to put t equals to 2 here, okay? T equals to 2 will give the position of the particle, but it did not start it from 0. If the particle would have started from 0, x equals to 0, then your answer would have been correct. But in this case, you have to be cautious. The particle starting from x equals to 40. So you have to write down the difference. This is 40 and this is 56. So particle has traveled only 16 meters. So B is the correct answer. B for Bombay is the correct answer. Okay. Coming to the next question. Again, see, some tricky part is there. Some maneuver is required. Some maneuver is required here. So it's been given that the particle is moving distance x in time t according to the equation x equals to t plus 5 raised to power minus 1. Okay. And they are asking to find out the acceleration of the particle in terms of velocity and distance. So you have to find out the acceleration of the particle in terms of velocity or distance. Okay. So what we are going to do here is velocity is what? Dx by dt. Velocity is dx by dt. Do it fast. So it's minus 1 t plus 5 raised to the power of minus 2. So we have got velocity as minus 1 upon t plus 5 power minus 2. So we have got this one as velocity, and then from here I can say velocity equals to minus t plus 5 raised to the power 2. Velocity is what? T minus t plus 5 raised to power 2. So we can say from here velocity is proportional to t plus 5 power 2. So t plus 5 is basically proportional to root v. From here t plus 5 is proportional to root v, and again I am doing one more differentiation. So acceleration is what? dv by dt. dv by dt, so it will be minus 1 into minus 2 into t plus 5 power minus 3. So acceleration I am getting as 2 times t plus 5 power minus 3. And I know that acceleration is proportional to t plus 5 power minus 3. So t plus 5 is what? Root v. So acceleration is proportional to t plus 5 is v power 1 by 2 power minus 3, velocity power 3 by 2. So acceleration is proportional to velocity raised to the power of 3 by 2. So just take the calculation. So displacement was given. From displacement we calculated velocity. This is minus 1 into t plus 5 raised to the power of minus 2. From here we got velocity as minus 1 divided by t plus power 5. It will be plus 2, right? Or we can say that velocity is minus 2. This is minus 2. Minus 2. T plus 5. I've done some calculation mistake here, I guess. So velocity is proportional to t power 5 minus 2. I'll do it again. No problem. Some calculation error is there. Sorry for that. Okay. So velocity is proportional to t power 5 power minus 2. Okay. So from here I can say that V is proportional to 1 upon t plus 5 power 2. So t plus 5 is proportional to 1 by root V. Okay. This is what the correct answer. T plus 5 is proportional to 1 by root V. Now differentiating it one more time, acceleration is what? 2 times t plus 5 raised to power minus 3. So acceleration is what? 2 times, and t plus 5 is raised to 1 by root V, means V power minus 2. So this is V power minus 1 by 2 minus 3. So acceleration is proportional to 2 times V power 3 by 2. The acceleration is proportional to V power 3 by 2. So this is the correct answer. B is the correct answer. So guys, there was some calculation error. So now this is correct. Okay. So you can see here what I have done is, I have first this expression was given to us. From this expression I differentiated and calculated velocity. Once I have calculated the velocity, then my final answer are in terms of velocity or in terms of distance. So what I have done is, I find out the relation between t plus 5 and velocity, and I've got that velocity is proportional to 1 upon t plus 5 whole square. So t plus 5 is proportional to 1 by root V. And then I have calculated, I have differentiated this expression one more time, calculated the acceleration, and in my acceleration expression t plus 5 is replaced by 1 by root V, and we have got the final answer. Okay. So moving to the last question of the day. Again, see, this is an important question. A particle starts from rest with some constant acceleration, and the ratio of the average velocity to the time average velocity. The ratio of space average velocity to the time average velocity. It should be space average, okay? The space average velocity to the time average velocity. The ratio is required, okay? So what do you mean by time average and space average? So let's say we have to find out the average velocity. We have to find out the average velocity. So average velocity is what? It is V dt upon integral dt. And let's say we have to find out this average from 0 to capital T. So in this region I have to find out the average. So this is time average. This is time average. And the space average is what? Integral. It will be V dx upon integral dx. And again, we have to find out this, let's say between 0 to capital T, 0 to capital T, okay? So this is space average. I have averaged the velocity over a certain space or up to a certain displacement. So this is space average. Space average. So we'll calculate both the expression and then we'll find out the ratio. So calculating the first one, so this V average is what? Integral V dt. And how do we write velocity in terms of time? Let's say starts from rest, it means the initial velocity is 0 with constant acceleration. A is constant. It means I can use the equations of motion. So I know that V equals to U plus AT, right? So this is 0. So velocity can be written as acceleration into time. So at dt, and this is from 0 to capital T divided by integral dt, and the limit is from 0 to capital T. A outside, this is t square by 2, limit will be t square divided by capital T. One t will get cancelled. So a by 2 into t. This is the time average velocity, okay. Similarly, we'll also find out the space average velocity. When taking the ratio, this value will come out to be 4 by 3, okay. This value will come out to be 4 by 3. So time average divided by space average, when we'll be doing, we'll be getting the value to be a by 2, okay. So if you want, I can also help you solve this particular part, okay. Yeah, so I'll be doing that for you. So this is space average is what V average. I'm doing space average, okay. This is integral V dx upon integral dx, and we are doing from 0 to capital T, okay. So what I'm doing here is V multiplied by dx. So let's divide it by dt and multiply it by dt, okay. Integral, I'm getting here integral dx by dt into dt, okay. And let's say limit from 0 to capital T. So dx by dt is v only, right? So this is integral v square dt upon integral v dt. This is from 0 to capital T, this is from 0 to capital T. Now just you have to put the limits. So this V average over the space, this is what integral, this is V square, right? So V is what, U equals to V equals to U plus 80, na? U plus 80, U is 0. So V square will be A square T square, A square T square dt upon integral at dt. The limit will be from 0 to t. Just solving it. A is constant, so A square will come out of the integration. This is t cube by 3. So this is t cube divided by A outside. T dt is what, t square by 2. So this t will be there. And then this is what? A square by 3 into 2 by A. And then t will be here. Okay. So one A will get cancelled. This is 2A by 3 into t. Now just you have to divide it and you will have to get the answer. So what we are supposed to find out here, the ratio of the space average velocity to the time average velocity. So time average velocity was coming as 80 by 2 and this is 280 by 3. So V average over the space, V average over the space divided by V average over the time. It's a very good question. This is 280 by 3 divided by 80 by 2. So this 80 will get cancelled and it will be 4 by 3. So the correct answer is what? 4 by 3. I hope this is clear to everyone. So in this slide, I am leaving some questions for you to solve. Just go through these questions and whatever I have taught you, try to apply these concepts and try to solve most of the questions. And if you have any doubt, you can put up in the comment section and I'll be more than happy to answer your queries and questions for this session. Thank you guys. Thank you so much. Keep hustling for your dream college. Work hard and be serious till your NEET exam. Thank you so much, guys.